Welcome to 6th grade math. That was a homework that was due in Google Classroom. Decimals and whole numbers. Any whole number can be written as a decimal. So 5 can also be written as 5.0 and can also be written as 5.00. 50 can also be written as 50.0 and can also be written as 50.00. It is important to line up decimal points when comparing decimals. Graph paper is very helpful when lining up decimal points. So there's a graph paper we're going to use for this next part. And compare the following numbers: 15, 14.95, 15.8, and 15.01. So we're going to line up 15 with a decimal, and we will add 2 zeros because we know that the next number, 14.95, has 2 decimal places. That has tenths and hundredths, so we need 15 to have tenths and hundredths as well so that we can line up the decimal points. And then we're going to add a 0 to 15.8 so that we can line up the decimal points again. And we don't need to do anything to 15.01 because it already has, it's already out to the hundredths, so we can line the decimals up. Notice that we added zeros to the right side of the decimal points as placeholders so we can line up the decimal points. And we can add zeros to the right of the decimal point and to the right of the last number as a placeholder without changing the value of the number. So 15 has the same value as 15.00. We haven't added anything to 15. We've just added zeros as placeholders so that we can add these up. Annex zeros. Place zeros to the right of the last digit in a decimal. So that's all we did. We annexed zeros in the 15. We annexed a 0 in the 15.8. Get ready for the lesson. Subways, refer to the table. World's largest subway systems. So it lists 5 cities and how long each subway system is. So which city has the longest subway system? If we look at the data, looks like the biggest number is London with 4.15 kilometers. 4 is greater than the whole number part of any other subway system. So that means 4 is bigger than the whole number part for Moscow is 3. The whole number part for New York City is 3. The whole number part for Seoul is 2. The whole number part for Tokyo is 2. Comparing decimals is similar to comparing whole numbers. You can use the symbols greater than or less than to write an inequality. In an inequality, a mathematical sentence indicating that two quantities are not equal. One quantity will appear greater than or less than the other quantity. Compare decimals. Refer to the table, use greater than or less than to compare Tokyo's subway length with Seoul's. So use place value. First line up the decimal points. We have Tokyo 2.81 and Seoul at 2.78. Then starting at the left, find the first place the digits differ. The whole number part for both subways is 2. So far they're equal. And we need to go to the next number to the right to see if they're different. Tokyo is 8 tenths and Seoul is 7 tenths. Since 8 is greater than 7, 2.81 is greater than 2.78. Tokyo has a longer subway than Seoul. Here's a number line, and if we were to plot 2.75 and then find 2.78, the number line shows the answer is reasonable. Numbers to the right are greater than numbers to the left. So we see that 2.78 is to the left of 2.81. So we know that 2.81 is bigger than 2.78. And this is just a little visual to show you that as you move right on the number line, the numbers get bigger. So that cone gets thicker, which indicates the numbers getting bigger as we go. Check your progress. Subways, refer to the table. Use greater than or less than to compare New York City's subway length with Moscow's. So use place value and line up the decimal points. So New York City, 3.71, and Moscow, 3.40. So starting at the left, let's find the place value that differs. So the whole number part for both subways is 3, and I've highlighted that there. And then if we look to the tenths place, we see that New York City has 7 tenths and Moscow has 4 tenths. Since 7 is greater than 4, 3.71 is greater than 3.40. New York City has a longer subway than Moscow. So let's go to the number line again. And if we look at 3.40 and 3.71, we see that 3.71 is larger than 3.40. Equivalent decimals. Decimals that name the same number. Examples are 0.8 and 0.80. So 0.8 is 8 tenths. So we have 10 columns and we've shaded in 8. So that's 8 tenths. But now if we want to look at 80 hundredths, we have, looks like a similar size grid, but instead of just having 8 columns, we have 10 columns. Instead of having 10 columns without, that aren't divided up, on the right, we have 10 columns of 10 rows. So we have 100 hundredths and 80 hundredths. And these are equivalent. So if we annex zeros, place zeros to the right of the last digit in a decimal, you'll notice that 0.8 and 0.80 are really the same number, except that we've annexed a 0 on the end of 0.80. Example, order decimals. So order 15, 14.95, 15.8, and 15.01 from least to greatest. First, line up the decimal points. So we have 15, we have 14.95, 15.8, and 15.01. So next, we're going to annex zeros, so all numbers have the same final place value. So we're going to annex 2 zeros to 15 to get 15.00. We don't have to do anything to 14.95 because it is the one of 2 numbers that are out to the hundredths already. 15.8 is to the tenths place, so we need to annex a 0 to get it to the hundredths place. And then 15.01 is already to the hundredths place. Finally, compare and order using place value. So we're going to order these from least to greatest. So we'll start with 14.95, 15.00, 15.01, and 15.80. And so the order from least to greatest is 14.95, 15, 15.01, and 15.8. And notice that we've just taken the zeros back off so that they are the original numbers. And remember, the entire time, they were still the original value. Comparing and ordering decimals. Order 35.06, 35.7, 35.5, 35.849 from greatest to least. So greatest to least, not the other way around like last time. So we're line up the decimal points, and we notice that the biggest, or not the biggest number, but the number with the most decimal places is 35.849, which goes out to the thousandths. So if we're going to annex zeros, we need to add a 0 in the thousandths place for 35.06. So we're going to add a 0 there. 35.7 goes to the tenths. So we need to annex a 0 in the hundredths and thousandths place. And then 35.5 is in the tenths place, so we need to annex zeros for the hundredths and thousandths. and then 35.849 is all set. So now we're going to order these from greatest to least. So 35.849 does happen to be the greatest number, but not because it had the most decimal places to begin with. And then 35.700, 35.500, and then 35.060. So then if we just go back and remove the zeros back to the original number, that's the order that they are in. And remember that whether they have the zeros on them or not, the values of every single one of these numbers never change throughout this entire process. Additional examples. The table below lists, and it's actually to the right, the table lists the final winning percentages for several American League Baseball teams in a recent year. Use greater than or less than to compare New York's percent to Cleveland's percent. So we have New York at 0.594 and Cleveland at 0.562. So New York 0.594, Cleveland 0.562, and New York is greater than Cleveland. And if we look at it from left to right, they both have a 5 and a tenths place, but in a hundredths place, New York has a 9 and Cleveland has a 6. And we know that 9 is greater than 6, so 0.594 is greater than 0.562. Order 25, 25.1, 24.36, and 25.03 from least to greatest. So we'll line up the decimal points and notice that 25 has no decimal places. 25.1 is to the tenths, 24.36 is to the hundredths, and 25.03 is to the hundredths. So we need to annex zeros on 25 and 25.1. So 25.00, 25.10, and then we'll just bring 24.36 and 25.03 over. Finally, compare in order using place value. So we're going from least to greatest. So 24.36 is the only one below 25 in the whole number. And then we need to look at 25, 25.1, and 25.03. So there are two that have a 0 next, 25.00 and 25.03. So we'll have to go to the hundredths place. And 25.00 is lower than 25.03. Then we'll bring the 25.03. And then because 25.10 has a number in the tenths place, that is the largest. The order from least to greatest is 24.36, 25, 25.03, and 25.1. Notice that we have removed the zeros. And once again, we have never changed the value of any of these numbers, even though we added zeros to the right of the last number. Here is your homework. There is a Google Sheet set up for you. So if you could go there and enter your answers, that would be great. I hope you have a great rest of the day. Thank you.